Sir, good afternoon.
Good afternoon. Can you all hear me?
Yes, sir, I can hear
Audible,
you.
audible.
Okay. If that's
So,
the
Dr.
case,
Siva, sir,
yes.
on behalf of Second International Conference, I welcome both of our session chairs, Dr. Sivakumar, sir, and Dr. Vivek Kushwah, sir. Sir, thank you very
Thank
much for
you.
accepting
Thank you, sir.
our
Thank you.
invitation to become the part of this conference.
Thank you, sir.
So, any guidelines on how long the presentation should be?
Sir, I will dictate you. Basically, total 8 paper has to be presented in your this session. Every paper you have to give 15 minutes time, 10 minutes for PPT, 5 minutes for the query. And please inform all the participants that during their presentation they have to switch on their camera so that we can do the recording. And in your presentation sheet, you have to mark the author name who is going to present the paper so that it will be easy for us to prepare the certificate for them.
Okay.
Okay, sir. Okay.
So, sir, what's the time in Malaysia?
4:55 p.m. We are two and a half hours
Okay.
ahead.
It's morning.
Yeah, today we have total 3 technical sessions. In the morning, we started with technical session 6. Professor Kamran Hassan is from Malaysia itself, so University Kapingshan, Malaysia. UKM, I think you know.
Aziz, sir, your voice is breaking.
Yeah.
Voice is breaking.
Yeah.
Just wait, sir. So now it's okay?
Yes.
Yeah. Now it is audible.
Yeah, thank you.
Sivakumar, sir, nice to meet you, sir, on this platform. Nice to meet you.
Yes, sir. Same here. Nice to meet you too.
There is a time limit for 10 minutes, no, sir? 10 minutes for presentation
Yes.
and 5 minutes for question answer session.
Yes. So, sir, I will introduce the authors and their paper title. Then maybe you can monitor on the timing and intervene 10 and 5 minutes. Then you tell the presentation for this session has ended. Then I'll move on to the next paper. Is that okay?
Yes, sir.
Okay.
Just a minute.
Sir, it is 2:28 p.m. in India. So in next 2 minutes we are going to start, sir. Basically, we have given 2:30 p.m. time.
Yes.
Yeah, Miss Kritika, please proceed.
Yes, sir. Good afternoon, all. Moving on to technical session 8, I would like to introduce our session chairs, Dr. Sivakumar Sivanesa, Associate Professor, Head of Schools, Schools of Engineering, Malaysia, and Dr. Vivek Kushwah, Chaitanya Bharthi Institute of Technology, Telangana. Firstly, we have Dr. Siva. Dr. Siva is a professional engineer with 23 years of experience with brands like Panasonic and is currently working with Asia Pacific University. He launched his engineering career with one of the largest cathode ray tube manufacturing companies in the world, and out of sheer passion, pursued his postgraduate studies. His enthusiasm to seek new knowledge, coupled with a compelling vision to produce engineers capable of addressing global challenges through effective enhancement of knowledge, nurturing of skills, and an emphasis on emotional intelligence propelled him towards the academic field in which he has remained for past 15 years. His extensive knowledge and experience within the manufacturing industry, complemented with a PhD in engineering, sets him apart from the other engineers. And as he is able to bring the industry into the classroom and provide valuable real life engineering experience to students. His experience as a team player and a team leader proved to be noteworthy in academia as he had successfully obtained national recognition for two engineering programs at the foundation and postgraduate levels respectively. Moving further, we have our next session chair, Professor Vivek Kushwah. He is a professor in Electronics and Communication Engineering Department of Chaitanya Bharti Institute of Technology, Hyderabad. He received his BE, MTech and PhD degrees in electronics engineering from Rajiv Gandhi Technical University, Bhopal. He has more than 16 years of teaching, research, and administrative experience in academics. His research areas of interest include artificial neural network, microstrip patch, antenna, wireless communication, 6G network, RF, and microwave filters, etc. He is associated with many IEEE international conferences as publication committee chair, session chair, reviewer, and conference committee member around the world. He is member of Academic Council of PK University, Shivpuri, nominated by MP Private University Regulatory Commission, Government of Madhya Pradesh, India since 2019. Presently, 5 research scholars are pursuing PhD under his guidance and awarded 4 PhD degrees, 92 BTech, and 1 MTech degree under his supervision. Member of many professional bodies such as Senior Member of IEEE USA, Fellow IETE and IET UK, etc. He published 24 patents and 5 patents have been granted. He published 2 books, 5 international book chapters, and more than 130 research papers in various reputed international and national SCI, Scopus, WOS, index journals, and conferences throughout the world. Now, I would like to invite the respective session chairs for proceeding up the session.
Thank you, Madam Kritika, and a very good morning and welcome, Professor Vivek, to TS-8.
Yes, so thank you, sir. Thank you so much.
A very good afternoon and a very good morning to all the participants who are here. We have 8 papers to be presented in this session, and without much further ado, I would like to call upon the presenter for the first paper. But just before we start the presentation, I think some simple rules. Each presenter will be given a total of 15 minutes for the entire presentation, out of which 10 minutes will be devoted to your presentation, and another 5 minutes will be devoted for the question and answer session. This whole session will also be recorded for the award of a certificate and the proof of attendance. Okay, so we'll call upon the first paper, paper ID ICWTNS-2024 157, entitled Multi-modal emotion recognition, fusing audio features with recurrent and convolutional neural networks by Aanchal Phutela. Thank you. Aanchal, the floor is yours.
Yeah, Miss Anchal. Anchal Phutela. Hello,
Yes.
Miss Anchal. Okay, Miss Anchal. Hello, hello. Yeah, Miss Anchal Phutela.
Yes, sir.
Yeah, please present your paper.
Sure, sir.
Yeah. Yeah. Thank you.
Very good afternoon to everyone. Is my screen is visible?
Visible, visible.
Yes, yes.
Okay. So shall I start with it, sir?
Yes, please.
Yes, please.
Thank you. So basically, we had done our work on the multi-modal emotion recognition systems. So for the emotion recognitions, we had used the audio files. Means we had used the audio data to recognize the feature to recognize the emotion of a person. So going with that, what I'm going to cover in this presentation today. I will explain firstly the block diagram we had designed for the proposed work, then the methodology we had used in our paper, then what are the software setups or software dependencies we require for this work, and then I'll show you some results, that is the model comparisons we have done. Before that, we will also try to evaluate our system by using some matrices of the machine learning process. Then I'll conclude this presentation. So going with this, as we can see in this diagram, we had proposed our system by using the convolution neural network and RNN, that is your recurrent neural network approaches. So we had worked on the feature set of the data. As we have seen in the previous works or the literature work, the authors have used one of the model to get the feature set, but we had applied the hybrid model architecture in which we had used the convolution neural network. With that, for this we had analyzed the spatial patterns of the data, and for the spatial patterns we had extracted the feature set from the audio data that I'll explain in the later slides. Then we had with CNN we had also used RNN model to capture the temporal dependency of the audio signals. So this approach, this hybrid approach, will basically help us to get more feature set to process the data. So coming to the methodology we had used to get the exact amount of features from the dataset. As I told, we had used the audio files as an input. Basically, we had used two of the dataset publicly present on the Kaggle. One is your temp emotion data, and another one is the RevDes dataset. So from that dataset, we had used only the audio modalities of the data to recognize the emotions. So for the second step, we had pre-process our audio files. For the pre-processing, basically, we have not used the exact full audios. We had used some windows of audios. So windowing has been done, and we had used, I think, 4 seconds of window to extract the feature set, so that we can reduce the computational of the model. So the next thing we have done, we had extracted the features from those audio signals that we have done through the pre-processing. So the feature set for the audios, we are having a multiple features that we can extract from the audios. That is, for example, we are having zero crossing rate, we are having noise to signal ratios. But all of this, the MFCC is one of the most efficient feature extraction technique which we had used in our data for our data sets. And from this we had extracted almost 40 mel coefficients, which is which helps us to get most of the features from the data. After the feature extraction, we had used this hybrid model, where we had combined the layers of CNN model and RNN model, and the feature set we extracted from the audio has been passed through these layers. After these layers, as we can see in this diagram, we had used the convolution neural network layers. After then we had done the batch normalization. Then we also applied the max pooling part, and then we also done the average pooling part. So even after this, we came with a dense layer of data, and after this dense layer of data, we also applied the LSTM model to get the LSTM model to get the features we actually want to recognize from the audio files. So from the dense layer, after the dense layer we flatten our layers, and we generate the output by using the softmax by using the softmix optimizer, and the learning rate we had used here as a hyperparameter is 0.001. So these are the software requirements which we had used, and these are the dependencies we used as a when as a code. So these as per these libraries are compatible with each other when we run the code. So these compatibility need to be in the coverage when we use this data. So coming to the evaluation of the model, so when we see the model evaluation, first figure number 3 actually tell us the loss we have done. So cross and drop we have seen in the data. So actually, sir, we actually trained our model twice. So here it is showing ki we are having. So this orange line shows us the validation loss, and this training blue line shows us the training loss. So we can see that when we are doing the training to our model, we are having a very good accuracy. But when we talk about the loss, it's our accuracy is quite less. So but we can see that after some 80 epochs we are getting a good accuracy, means the loss is decreasing. So when the loss is almost 20% when we are here, this is actually because which we again trained over the weights we got from the model. So that's why the loss here it is showing more. So we got almost 80% of the accuracy when we validate our data. And as per the training validation and testing data, we had split our data into 80-10 or 10 ratio. So in the second figure number 4, we can see that when we go for the which is a between epochs and accuracy. So as per our epochs are going to be after 60 or 80 epochs, our accuracy is almost stagnant. So we almost got 80 to 90% the accuracy for this model which it represents. And this is the confusion matrix for our different types of emotions. So our prediction is a multi-class category, multi-classification data. We are having 7 emotion classes which we had predicted. So this is the model comparison. As I told you, our model had the precision of 80% and accuracy of 78%. We had also performed the same thing on other models as well, where we had used some machine learning model, traditional machine learning model, which have shown a very less accuracy as compared to the our existing deep learning model. So this is the which is actually outperformed out of all these. So basically, the conclusion of our work is RNN and CNN. Basically, the deep learning approaches has outperformed over the traditional machine learning approaches due to the feature extraction part. Because in machine learning, a traditional machine learning model, we manually extracted our features. So deep learning actually do their job best for us. So deep learning has outperformed for this work. And the most crucially, we also want to improve our system by calculating the emotion value in the future. So this is our future work for the current thing. So another than that, the concepts can already be stretched by the other usages such as feedback systems, personal blogs. So basically, this work can be used in multiple domains like in entertainment, in marketing, in reviews. So this work, this emotion representations can be used in emotion in various platforms. For example, one of the way we can use, like we are watching the YouTube videos and we can see the reviews on it. What is the emotion for the speaker. So as companies recognize the critical importance of the emotion classification to the proactive consumer engagement, personalized interactions, and improved decision making. So this actually plays a very important role in this field also. So this is how our work is, and we have presented this work in the conference. Thank you so much for your
Thank,
time and attention.
thank you, Achal. Thank you. Any question by any participants? Achal, I have a question regarding this.
Sure, sir.
How your work is, difference? How it is different from the existing works which is already available?
Sir, in the existing work, the authors have been used the traditional ML models, or even they had used the binary classification for the emotions. So we had in this work we had used the deep learning models as compared to the traditional models, and with that we had used the hybrid architecture of the DL models, which actually helps us to extract the more number of features, so that we can easily classify our multi, because we are having a multi label of data here, not the binary data we are classifying.
Okay, thank you. Thank you. Sir, would you like to ask any?
No, I'm okay. I'm fine. Thank you. Thank you.
Okay, any participant? Any question? I think there is not any question.
Okay.
Okay, sir, we will proceed to next one.
Yes.
Okay.
Okay. Thank
Thank
you,
you.
Ms. Aanchal, for that wonderful presentation.
Thank
We
you,
shall
sir.
now proceed to our paper ID number 295, entitled Analyzing Toxic Tweet Sentiment Using NLTK in Python, a computational approach by Ayush Yadav, Akshat Bisani, Adarsh Dixit, Yogesh Patil, June A. Sid-diqui.
Yeah, Ayush Yadav.
Hello, good afternoon, sir.
Okay, please.
Sir, I am Adarsh Dixit.
Yeah, please turn on your camera. Others,
Sir,
your camera, please. Yeah, thank you.
sir. Sir, am I visible, sir?
Yeah, you're
Yes, you're
visible.
visible. You
Visual
can
as well
start.
as audible.
Okay, sir. So, sir, on behalf of my group, I'll present the presentation today.
Yes, carry on, carry on.
Sir, is my presentation visible, sir?
Yes.
Yes.
Okay, sir. Good afternoon, all. So, we made our project on toxic tweet sentiment analysis. So, it is basically, sir, as we see, uh, as we see in our changing environment,
Yeah, please.
especially on social media platforms,
Please keep it full screen.
we see.
Full screen. Slide show.
Okay, sir.
Full screen. Yeah. Yeah. Now it's good.
So, sir, as we see on social media nowadays, we have very toxic tweets. Uh, Mainly, we are seeing the trollings on various platforms. So, our our goal is to analyze those toxic tweets and categorize those toxic tweets in different categories, and to modify those toxic tweets to make the environment on social media safe and content free. So our abstract is this project focuses on developing sentiment analysis techniques, sir, to identify, classify toxic tweets, addressing the growing concern of negativity on online communication. Sir, so our ultimate goal is to modify those toxic tweets so that the public on this platform feels safe. This project delves into the development of sentiment analysis system tailored to identify and categorize toxic tweets by combining natural language processing and machine learning techniques. Our goal is to create a tool capable of automatically detecting and mitigating harmful content, contributing to a safer online environment. So what we are doing, sir, we are making a model using SDM or LSTM models we are using, and through the training data set we are training our model. So when any of the tweets available on social media is harmful or is very not good for the content, so it automatically categorize those sentiments of that tweets in a harmful or non-harmful category, and it modifies it. So the our problem domain is this analyzer aims to address the following challenges: online harassment, hate speech, affect user safety, damage to mental health, affect platform reputation and user experience. So our solution domain is, what we are doing is, first of all, whatever tweets, whatever harmful tweets on social media is there, we are streaming it or directing it to our classifier using our TP library in Python. So in this classifier, that particular tweet will be categorized as harmful in which category it is going. So then we process these tweets so that they can be fit for mining and feature extraction. After the feature extraction process, we are processing this data to a trained classifier, which finally will classify this data into positive or negative class based on trained results. So our main application domain is on social media platforms, online communities and forums, brand reputation management, public relations and crisis management, government and regulatory bodies, technology companies and media and journalism. As you can see in this diagram, how the tweets are collected and how these tweets are retrieved and how the analysis has been done on the based on our training data what we have put into our system. So these tweets are expected and the features of these tweets are being categorized in various categories based on our training data what we have put into our model. After analyzing this data, and toxification is done based on the harmful words it catches in the whole sentences. The whole sentences is being converted into a very few words, which is our keywords, and on the basis of those keywords, we analyzes the complete sentence whether it is a sentimental, harmful, or sentimental retrieval. So first, our tweet retrieval is done. We pre-process that tweet as as it can be a very big sentence. We break those sentences into those keywords which will automatically categorize the data. And after that, tokenization is has been done. Tokenization means it will be categorized into different forms, whether it is an emotional sentiment, whether it is an body shaming sentiments, whether it is a happiness sentiments, based on those sentiments, and then it will more generically divided into negative tweet or positive tweet. Based on those tweet, they will actually modify that tweet and present back to the content. This is our sir, system flow diagram. How the our training data is actually training our system model, and how our model is classifying the new data, and how it is predicting whether the data is being harmful or sentimental or not. So the main methodology we have used is data collection, pre-processing, feature extraction, word embedding, training data and evaluation metrics. The main tools and technologies used in this, we have used the programming language Python, natural language toolkit NLTK, and system model we have used SVM, support vector machine, LSTM. This based on our sentiment score, our data has been categorized. How intensive the data has been, how intensive the harmful sentiments, harmful tweets has been. On the basis of that score, we have categorized is whatever the limitation of this. We are still in a building stage. We can update this model by actually updating the training data regularly, and as we regularly train our data, it will be more precise. So what now the limitations are privacy concerns, lack of context awareness, generalization issues, bias in training data, ethical considerations. The future of scope of this toxic tweet sentiment has been very categorizable. Additionally, collaborative research efforts and establishment of regulatory frameworks are expected to shape responsible content moderation practice in the evolving landscape of online communication. So, sir, this is our conclusion. Toxic tweet sentiment analysis is vital for addressing harmful content on social media. Transparency, context awareness, and real-time detection are crucial for effective content moderation. So, with more training data, with more upgradation, it will be more accurate and make the social media platform more safer and less harmful to the user. Thank you, sir.
Okay, thank you. Any question by any participants?
Maybe
Yeah.
just one question by me, Vivek sir. You
Yes, sir.
don't- Yeah.
Yes, sir. Please.
Uh,
Sure.
Mr. Akshat, right? Yeah. I didn't see a slide on objectives to show any tangible achievements that you're trying to that you've achieved in this paper for your presentation.
So, sir, we are trying to actually analyze is what nowadays we see the more trolling on social media. Somebody is body shaming someone, and nothing has been done till now. Nothing legally has been done till now. So what our aim is to actually retrieve the data and to categorize that if that particular troll is body shaming or so what we are doing is we are modifying those trolls. We are modifying those comments based on the particular keywords.
Okay. Thank you. Thank you.
Thank you, sir.
Okay, thank you. Thank you, others. Any other
Thank you, sir.
question by any other participants? If there is not any question, then sir, we can move to the next one.
Okay.
Thank you,
Once
others.
again, thank you, Adarsh, for that
Thank you, sir.
wonderful presentation.
Thank you
Um,
so much.
we will now move on to paper ID number 307, entitled An Efficient Dual Learning Spatial Multiple Criteria Analysis Approach to Identify Suitable Sites for Renewable Energy Development Within Environmental Impact Assessments by Kapil Adarwag. The
Kapil,
floor is yours, Mr. Kapil.
Mr. Kapil, please join. Mr. Kapil is here. Mr. Kapil. Mr. Kapil, I think, sir,
He's
he is
not
not.
here.
No.
Yeah, okay. So we'll move on to the fourth paper, paper ID number 287, entitled An Advanced Multilingual Deep Learning Approach for Semantic-Based Sentiment Analysis by Praloy Biswas,
Yes,
Sukhvindra Guha, and Daniel Arokiam. Daniel Arokiam.
sir. Good afternoon.
Good
So
afternoon.
I will going to present the paper. Firstly, thanks Ashish sir for giving me the opportunity for presenting the paper. Yeah.
Thank
And
you.
thanks the chairs, probably Sivakumar and Vivek sir for organizing and giving me the opportunity to present the paper. So with your due permissions, can I share my screen?
Yes,
Yes, sir,
yes,
please.
sure.
Am I audible, right?
Yes, yes, you are.
Okay. Uh, so good afternoon, everybody, including chairs. So I today I going to present the paper called an advanced multilingual deep learning approach for semantic-based sentiment analysis. So this is the table of content: introduction followed by review of literacy, then current approach of multilingual sentiment analysis, drawback, existing methods, proposed methodology, experimental result, benefit of proposed approach, conclusion and references. So introductions: multilingual sentiment analysis capability for proposed work and multilingual sentiment analysis. Deep learning architecture, we will be going to discuss on the deep learning architecture. We will then in today's increased global and multilingual world, the ability to analyze the sentiment uh, and accurately and cross-language different become crucial. However, the existing methods face the challenge and handling complex linguistic like ambiguity and scam and often struggle to low resource languages. So mainly for cross language, we will be talking about the cross language, unified language, and language transfer efficiency, what is semantic presentation, and what is the robust performance. So we will be trying to discuss on this all points covering. So review of literatures, we saw some at least reads hundred of paper on the same domain, and we found there's a few of them, and we found there is little gap for different papers, and most of them gaps are regarding the struggle to negotiation context and complex linguistic phenomena like ambiguity and scam, human featuring engineering and lack of semantic understanding, did not complex semantic conceptual information, limited data set is available, that's a problem. Related parallel data and cross language embedding is a problem, dependent translation quality is a problem, lack of semantic modeling is a problem, and mostly focused on most of the data are focused on English, and for regional language it's a data set is a bigger problem. So current approach, if we're talking about current approach, we are in a nutshell we are talking about when we are talking about mainly transfer of learning. That's how the transfer learning is going on for multi-language. Most of the time we're doing a transfer of word to word transformation of each word, whatever we are used in the source language, and generally we are going for transfer this word by word transformation to the this English language. Then cross language embedding, we are utilizing the cross language embedding such as Moses and Lessers, which can capture semantic similar across language and enable develop multilingual semantic. Then we're talking about machine translation text and high resource language like English, then apply existing sentiment analysis model, however the translating results back to the original languages. Then code switching handling, developing the specialized model technique handle code switching into multilingual data, and where patient or provider switch between languages and same text. And multi-language text training sentiment analysis model join multiple languages on tasks such as named and entirely recognized relation data and covers and then improve performance. Data agnostic, we're talking about the data agnostication, generating the semantic data of multiple languages using technique like back translation and machine translation, domain adaptation, general purpose sentiment analysis by any domain feature or any semantic domain. And then we're talking about the INSEM methods. Is methods talking about that multiple sentiment analysis model obtain different languages using interoperability context aware model. So this is the current. We are talking about the ethical privacy and consideration. Also, implementing the when we are talking about the want to implement this model for the uh, different domains, we facing the issue of ethical and privacy consideration, particularly for medical field or some legal field. We have to consider that PI data is marked properly, and if PI data is marked properly and taking necessary action on that. So we are talking about the evolution and benchmarking, creating multilingual sentiment analysis data benchmark, and evaluating the developing a few new model techniques. So we are talking about the continuous learning, the develop whatever the models the currently working on, that should be developed and should be continuously learning when the time goes. Hybrid approach, combining the various approaches such as machine translation, transferring learning, adaptation, domain adaptation. So leverage a different approach to overall performance in multilingual sentiment analysis. We're going to the proposed methodology. So I think I should discuss it here more. So what's actually key things we want to propose in the our approach. So first things we want to propose that this model, whatever our model, that will be semantically informed pre-training model. So this model is pre-trained not just standard marks language like modeling objective, but also new semantic awareness phase prediction tasks by masking this our entire sentiment being phrase and train modeling predict their phase, and it enables the enable rich and semantic and contextual present by specific usual semantic analysis. Then it will large scale multiple language pretending it will be doing. The model is pretend on massive multilingual corpus spanning diverse language and domain and genres. So it will cover actually the model will be covers multiple domain, multiple languages, and so this allow is to learn transferability across language transformation that can be effectively adaptive the different languages, and will be provide some unified transform architecture. That model can provide the multi-layer transformation encoder uniform architecture that can seamlessly work for multiple languages without any major changes. Effectively multi language transformation by transferring that leveraging seamless informed returning languages and corpus and can be used here. And so in a summary, in a niche transformation, and we will be objective will be creating a multilingual pretending and unified architecture that's enable effectively cross language transfer for cementing language based on the sentiment analysis. So that is the basic goal of this proposed model. So if we're talking about more here, as it's the proposed methodology, because nowadays when we're talking, we're using mainly not a single languages. We are generally talking in a cross languages. In a particular language, if you're talking a single sentence, within a sentence also we are talking cross languages. So first we have to identify which word is coming from which languages and what is the mother languages of basically main languages of this piece, and what are the secondary languages that's used in the speech, and based on this secondary languages used in the speech, and based on that we have to, whenever we're doing a sentiment analysis, we have to consider all those factors, not only because it's a cross language, we have to be more careful. You cannot directly transfer these languages based on the mother language, source and destination language, because here we are not talking about one languages to another languages. Mirrorless, we are talking to multiple languages used in a single plate. So in the proposed methodology, we have used some tokenization algorithm, embedding and positioning, self-attention algorithm, phase tree algorithm, and context switching output. So experiment analysis result, if we're talking about, we are in this currently we are considering only mainly Indian languages like Bengali, Hindi, English, Telugu, and we are evaluation compare proposed several robust conclusion, and the data set used for basically Bengali sentiment corpus, Hindi sentiment corpus, English Amazon product review, multi-language sentiment corpus, Telugu sentiment corpus, then include the multi-modeling BART, cross language transformation, and multi monolingual BART. All those things have been used. We are basically calculating the F1 score and classifying accuracy and micro average F1 score. So we are calculating those. So if we look into that we are basically in our calculation the existing methods with the all languages and compare with the our proposed method, and we saw at least few cases or most of the cases our model give us a better result, because we are basically not considering a single language, we are only doing it for cross languages. So if we talking about confusion matrix, we saw that for confusion matrix the values are basically for predict positive and negative. So this is the pictorial representation of confusion matrix for English, this is for Telugu, and this is for English, this is for Telugu, and this is for Hindi. So if you look into that, still we in our model also there's the one problem that we are still not able to get 100% or maybe able to reach up to English, because English is still giving the highest result. So now we're talking about the proposed model are all baseline based on the F1 score most data set, and we are translate, train and cross language transform based on the perform poorly and possibly due to the lack of parallel data and potential loss of linguistical nonsense during translation. Quality analysis related to related insurance is the proposed model predict and sentiment analysis based on failed and case of ambiguity. So the authors include that proposed method will across the various languages including low resource languages like Bengali, Hindi, and like Telugu. So benefits several key proposed key proposed sentiment analysis proposed. It's effectively multilingual transfer things. The approach can be effectively transfer the semantic approach across languages, minimize the need of large amount of level data to target the language. This achieves the large scale multilingual pretending semantic informed data. So semantic aware presentations, the model attention based on the architecture and semantic aware and pretending object allow us to read semantic and contextual information leading to provide semantic prediction. We're talking about the language agnostic because we are down to propose a basically unified architecture that will be we can use it for any languages in any domain. Domain robustness, in this talking we are not going to consider single domain data. We are basically trying to use it for multi domains. Especially we have tested it for media, movie, and healthcare. Improve performance in low resource scenario, because as we are doing the sentiment based transformation, then we are applying the semantic based transformation, then on the data we are basically try to provide the sentiment. So as we are basically transferring those data into English or any high level languages, then are able to provide the basically improved result based on that. So handling the complex linguistic phenomena, this qualitative approach showed that learn proposed enable and effective handling complex linguistic phenomena such as ambiguity and contextual languages. And we are talking about the unified frameworks. That's the main advantage we are trying to propose here. So in the proposed conclusion, we are showing all the key, as a key pointer, and I already covered all those things. So thank you. So you have any questions?
Yes, any question by any participant? I think there is not any question. Yes, Parloy. Hello.
Yes, sir.
Uh, how it is? Give me some justification regarding the novelty of your work. Novelty.
Novelty means generally we are talking about either multilingual or single
Yeah.
lingual.
Yeah.
Where
Yeah.
we are talking about cross lingual, because in a single piece, if you're talking
Mhm.
about every day in a single statement, also you're using 2 3 languages. So, but problem is that if you just word by word, if you transferring, it will be problem. But if you understand the target languages, source languages, also it will be problem, because we are not talking on a single languages. We are talking on a cross language. Suppose in a single language piece, if you taking consecutively 20 or 30 words, it have a different languages. So first identify what is the primary languages there, what are the secondary languages there, not
Okay.
single languages, secondary
Okay.
languages also. So that is the beauty of this algorithm, that we have to identify first what is the primary languages, what are those secondary languages, and what is their basically priority of those. Because all the secondary languages, suppose I am talking on English, most of the time I whenever talking, if I'm using the second language, it's the Bengali. Third is Hindi. Fourth is suppose Telugu. So if I'm getting a word that is unknown to English, or this is not an English word, first I will be trying to check whether this word is coming from English, Bengali or not. Because at the speech, you have to first on the fly you have to identify what is the second language, what is the third languages, what is the fourth language. Based on that, we have to basically try to transfer this language, because one single word can be used in different languages and may have different meaning altogether. So for this reason, we have to first identify what is their preference. First user languages, then second languages, third languages. Based on that, you have to transfer this language when you are transferring the sentiment. Otherwise, it will be a massacre. Because if I use word, some word, suppose in my cross languages, I have a used Bengali word, and by wrong any chance you want to use understand this is the second language is Hindi, and you are trying considering this as a Hindi language, it will be giving this maybe nonsense word, maybe sometimes giving the negative impression also. So for this reason, on the fly, you have to identify which what the actual languages, source languages, if it is a cross languages, what are those secondary languages and what are the preference on that.
Okay. Thank you. Thank you. Thank you so much. Sir, may I call to next one?
Yes.
Yes.
Okay. Thank you, Mr. Praloy. Thank you for that wonderful presentation. Let's move on to the
Thank
fifth
you, sir.
presenter for today. Uh, paper ID 167. The title of the paper is Identification and Classification of Power Quality Disturbances via Synchro Reassigning Transform. Presented by either Roshan Kumar, Vikash Singh, Anuj Baral, or Vezal. So
Yes.
do we
Paper
have
number 237.
no, 167.
167. Sorry. Roshan Kumar.
Yes.
Hello, sir. Good afternoon, sir.
Good afternoon, Mr. Anul. Yeah, okay.
Yes, sir.
Please
I'm
say your
Anuj.
speech and carry on. Yeah.
I'm a fourth-year bachelor student studying in Manipal Institute of Technology. I'm studying electronics and instrumentation. So I'm presenting my paper. So yeah, the title of the paper is Identification and Classification of Power Quality Disturbance via Synchro Reassigning Transform. So the content of the paper is we will go through objective, introduction, what is power quality disturbance, the different techniques used to access the power quality disturbance, result and analysis, future scope, and finally the conclusion. So this paper presentation aims to explore the importance of time frequency techniques that is used in signal analysis. Particularly, we focus on power quality disturbance, and in order to access the power quality, we go through different techniques like short time Fourier transform, wavelet transform, synchro squeezing transform, synchro extracting transform, and finally the method that we are proposing, the synchro reassigning transform. So yeah, why time frequency technique is used? Because traditionally what we have seen, the signal analysis using only the amplitude time or amplitude frequency only gives us information regarding only the one aspect, that is either time or frequency. So it is important to understand about this signal using both time and frequency. So for that, we analyze the signal through different spectrograms, wavelets, etc. So before understanding that, first we need to understand what is power quality disturbance. So any abnormalities or deviation from the ideal electrical power supply is referred to as power quality disturbance. So ideally what happens is whatever the signal that we receive in our houses has to be a ideal sinusoidal wave. If any abnormality is here in that sinusoidal wave, we suffer from various disturbances. So that can be due to lightning strikes, sudden short circuit, equipment failure, I mean many things. So it's very important to identify these disturbances because it can lead to equipment malfunction, downtime, failure of the appliances. So disturbances like voltage sag, if there is sudden decrease in voltage and voltage surges, sudden increase in voltage can damage our sensitive electronic equipments. And disturbances like harmonics and interharmonics, which we specifically try to deal with this in our paper, also draws more current than necessary. I mean, there are many other consequences of it. So yeah, so these are the different power quality disturbances. First one is the voltage sag. If there is a sudden decrease in voltage, that may be due to short circuit of the appliances. Sudden increase in voltage swell, that can be due to lightning strike or capacitance switching or any internal duty of the appliance, and voltage interruption that can happen due to unnecessary turning of the appliances, short circuit, etc. And specifically harmonics and interharmonics. So harmonics, what we mean by this is, for example, the we can see from this picture that in the peak of the signal there are certain spikes. These spikes are normally the integral multiple of the frequency that we receive in our houses. In India, it is 50 hertz. So, for example, the first harmonic is 50 hertz, the second harmonic can be 100 hertz, third can be 150 hertz, like that. And due to that, we face different downtime on the electrical appliances. So yeah, so different techniques that we are using to access this disturbances is first using short time Fourier transform. So here what it does is it divides the signal into smaller segments. These segments are what we call as windows, and on these windows it applies Fourier transform. Fourier transform, as you all know, it's a amplitude versus frequency analysis technique. But the major disadvantage of this technique is the time frequency resolution depends mostly on the window size. So we try to address this by using other techniques. The other technique is one of the synchro extracting transform. So here also the signal is divided into smaller segments, but out of this segments we try to find out the maximum frequency component. We discard the other weak frequency components and we try to plot a graph of time versus frequency based on this maximum frequency components. So in this technique also, like since we discard all the other weak frequency components, this might hamper the overall analysis of our signal. So the other is wavelet transform and its variant synchro squeezing transform. So in wavelet transform, we use finite energy energy signal like Morlet wavelet. So that Morlet wavelet, it accordingly squeeze and scale itself to capture different signal features. And but it can have other disadvantages like the uh, time frequency resolution can be a little bit blurry due to Heisenberg principle, because it's really according to this principle, both the momentum and the position of the signal, like the analysis of both the time and frequency simultaneously, it is not possible. So for that also we use synchro squeezing transform, which is just a variant of wavelet transform, which enhances the wavelet by adjusting the wavelet. Basically, again, it squeezes and scale the and shift the wavelet so that the resolution that we get is not as blurry as we got in the wavelet transform. And finally, the method that we are proposing here is the synchro reassigning transform. So it's an advanced time frequency analysis. So what it does here is it identifies sudden increase or a decrease in frequencies. This is specifically helpful when dealing with harmonics and interharmonic signals. Once it identifies those areas where a frequency is suddenly increasing or decreasing, basically what we call as gradients, it then identifies the local maxima, because at the local maxima only the signal has the most information, like the energy of the signal is at the utmost at the maximum level. So it then tries to dynamically reassign the uh, time frequency coefficients, and that's how it plots the new signal, basically the new TF representation. The signal, the representation that we get from this analysis is more sharper as compared to the other techniques, what we'll discuss here. So as we can see, this analysis for the harmonics and interharmonic signals disturbance. So from the STFT we get this, but we can see the harmonics that is present on the top is very blurry. I mean, we cannot say that it's really a harmonic disturbance or not. And finally, we see from other techniques also, like the wavelet transform, synchro squeezing transforms, synchro extracting transform, it's not visible also properly. But here in synchro assigning transform, we can see that the blue line on the top, it efficiently gives us a sharper depiction of the interharmonics and harmonics in the time frequency domain. So we try to basically try to see compare all these uh, techniques with the help of a matrix, that is the Renyi entropy. So Renyi entropy we choose because it's susceptible to noises, also different SNR values. So according to it also, we can see that the synchro reassigning transform, it has the lowest entropy. It means that it indicates a more energy concentrated TF representation, because basically a sharp representation as compared to other techniques, and is also susceptible to noise irrespective of SNR values and all. It gives us a clear representation, not only for harmonics and interharmonics, surprisingly for voltage sag also, for voltage swell also, and for voltage interrupt also. The synchro reassigning transform gives us the uh, optimal results. So the entropy here is the lowest. And yeah, that's what we discussed here, that synchro reassigning transform emerges as the superior time frequency analysis technique, as we discussed. And future scope we can do is, like, for the real-time monitoring of these signals, we can integrate with IoT systems, and we can use different chips like ATM90 for data acquisition, and the ESP32, etc., for which has Wi-Fi and Bluetooth capabilities for the IoT-enabled solutions, and also uh, for more advanced signal processing techniques. Apart from, say, with synchro reassigning transform, we can also use other techniques like empirical mode decomposition that we are looking for right now. And finally, like for automatic detection of this power quality disturbance, we can use neural networks like CNN, where we can train the STFT images or synchro reassigned transformed images into the neural network, and finally we can get the automatic detection of this. I mean, whether it is voltage sag, swell, or interrupt or harmonic, we can automatically detect this disturbances. So yeah, that was all. Thank you.
Yeah. Any question by any participants? Sir, would you like to ask any question, sir?
No, sir, I'm fine. Thank you.
Okay,
You
I
can
have a
go on.
question. I have a question on this single question. We are using this method. What is the name of this method? This whatever you told just now.
Synchro reassigning transform.
Synchro reassigning transform. That is used
Yeah.
for identification and classification of power quality disturbances.
Yes, sir.
But instead of this, if is there any other method which is available which gives us more efficiency better than this?
As of now, sir, we were majorly focused in detecting harmonics and interharmonic signals. So in this case, the synchro reassigning transform, the technique that we use here is the most optimal one. For the other classification of signal like the voltage sag, voltage swell, the normal traditional techniques like short time Fourier transform were also giving good results. But when we calculated the entropy of all these techniques, we found out that synchro reassigning was the most optimal one.
As per the recent research, it is the best method.
Yes, sir.
Okay, thank you.
Okay, thank you,
Thank
Mr.
you. I made it a little fast and quick. Okay.
Thank
Anyways,
you. Thank you, Mr. Anul Baraj. We'll now move on to the sixth paper, paper ID number 237, entitled A Compact Triangular and Semicircular Patch Antenna with Notching Characteristics by Jankam Sravandi, Gore Shrikant, Prirana Reddy Kota, Amok Shekhar Reddy, and KH Murli Naik.
Yes, sir. Good afternoon, sir.
Okay. Good afternoon, Ms. Jangam. You can proceed now, please. Thank you.
Yes, sir. I'm Jangam Shravanti.
Possible, please turn on your camera.
Yes, sir.
Yeah.
Is my screen is visible, sir?
Yeah. It is visual.
Yes, yes.
Uh, this is our project title, A Compact Triangular and Semicircular Patch Antenna with Notching Characteristics. I'm from Vadaman College of Engineering. So this is the outline of the project and the presentation. Starting with introduction. So here we have designed antenna, which is used based on the requirements we need, based on the applications. So we have designed an antenna. So let's go with the definition of the antenna. Antenna is a fascinating devices used for various fields like telecommunications, radar systems, and satellite communications. So here are some images of the antenna which we see in our surroundings. Coming to the fundamental principle of the antenna, it works based on the principle of electromagnetic wave propagation. uh, as you can see in the image, this is the transmitter and the receiver, where there are some waves propagating to each other. In this process, the alternate current flows through the antennas, which generates electromagnetic waves, which are propagated to the space. These carry some information like frequencies, amplitude, and some bandwidth ranges. They are used for wireless communications for short range and long range distances. Types of antennas, there are different types of antennas which we can use. based on the applications and based on the requirements we need, we have to choose the antenna which we have to design. So there are some wireless dipole antennas and monopole antenna, Yagi-Uda antenna, horn antenna, and parabolic reflector. So in our design, we have used monopole antenna. Design considerations are there are some considerations which we have to make sure of that before designing an antenna. The parameters should be correctly checked, and the geometry of the antenna, operating frequency, and we have to check the impedance mismatching and radiation efficiency and polarization of the antenna. So all these are done in a software called HFSS, ANSYS HFSS software, which is used to design an antennas, where we can design an antenna and apply some boundaries and apply some uh, space and with some metals. So here we have used a substrate called Rogers. Coming to the applications of the antennas, there are several applications of the antennas like Wi-Fi systems and satellite communications and routers, etc. Here are some pictures of the antennas. So objective, as I already said, that we have designed an antenna. So here is that we have designed a UWB antenna, which stands for ultra wideband range antenna, where ultra wideband ranges from 2 gigahertz to 30 gigahertz. So these design has been designed in HFSS software. We have already designed an antenna called fractal UWB antenna with the WLAN notch characteristics. From that, we have inspired that we have to make our own antenna and with some notching characteristics with different applications where it can be useful for multiple applications. Uh, Here are some literature survey we have done. This is a dual band notched CPW fed printed monopole antenna for UWB applications. It ranges from 2.48 gigahertz to 18.35 gigahertz. And in these, there are several slots which are the reason for the notching characteristics. So we have selected U and inverted U slots, which we can see here. This is a U slot and this is an inverted U slot. And this is a H slot, which is used for other applications. And this is another antenna, compact CPW fed UWB antenna with band notch characteristics and ISM band applications. Its gain is 1.4 dB and bandwidth from 3.6 to 4.7 gigahertz. This is also an antenna where it has a different dielectric constant and thickness. This is the flowchart of the project. First, we have selected the design parameters of the design, like substrate, operating frequency, and dimensions. So, operating frequency we have decided to do UWB, and substrate we have used Rogers, and dimensions based on the range we have got the results, and we have designed it in HFSS software and executing some boundaries and assigning some values to it and parametric analysis and simulations. After that, we have done some modifications based on the results, multiple results we have got. So the best one we have took it and we have put it over here. This is the proposed antenna, where this is the patch of the antenna and this is the ground of the antenna, where it is a triangular shaped ground, and this is a patch where it is designed using semicircular cuts and circle uh, design. These are the notches, reason for the notching characteristic. This is a U slot and this is an inverted U slot. This is a VSWR plot. So UWB with notches, we are getting the notches at 6.25 gigahertz and 9.25 gigahertz. This is a parametric study of varying ground structure. First, we have varied the ground structure with different parameters. This structure 1 shows the different parameter of the ground structure, and this is the graph of that. the green line, and structure 2 is the blue graph, and the structure 3 is the red graph, which these graph gave us the best results in UWB. It is below the 10 dB, minus 10 dB. So this gives us the exact UWB range, and this is the resonant frequency, the which is very narrow and it is very good. So we have selected the structure 3, and this is the UWB. This is the VSWR graph where it should be below 2. The red one gives us the exact VSWR plot. So we have chosen the structure 3. This is the parametric analysis of the notches. By varying the notch parameters, we have got different uh, graphs. So the red one we have to has the final one, which gave us the exact application notch, that is 5G WLAN, where it is ranges from 6.3 gigahertz, and this is the X band. It is from 9.25 gigahertz. This came due to the inverted U slot, and this is the current distribution of the antenna, where the middle part shows the how the current distributed over the notching characteristics. These are the notches around that, how the current is distributed. These pictures shows that this is from E field and this is from H field. And antenna efficiency and gain, the left graph shows the antenna efficiency. So has you can see that this is the mark where it shows the antenna efficiency. So from the software we have done, there it have we have got that 96% efficiency of the antenna, where it uh, receives the 96% information and rejects the other 4. So it is very optimal and used for different applications. And this is the gain graph, where we have got 4 dB. These are the radiation patterns in E field and H field. So based on the antenna we have designed, these are the applications. On X band, we have several applications like military and government institutions, and weather monitoring and traffic control, etc. And WLAN applications are like wireless devices, like Wi-Fi, and which is used to connect it to the laptop and printer and mobile phone and many other applications. So conclusion of the project is, we have designed a UWB antenna which is giving us a UW frequency of 3.86 to 21.06 gigahertz, and a VSWR of below 2, and it also with the notching characteristics of 5G LAN and X band frequencies ranging from 6.3 gigahertz to 9.2 gigahertz respectively. And our antenna also has a radiation efficiency of 96% and gain of 4 dB. These are some of the references which we have gone through. Any questions?
Yes, any question by any participants? Yeah, I have a question actually. I have a question one.
Yes.
Have you fabricated this antenna and measured the result in the laboratory?
Yes, sir.
So
Like,
where is the fabricated prototype?
we did not fabricate it, but we have gave it to the fabrication, but we did not mention it in the paper.
Okay. And what is the graph between return loss and frequency? Have you drawn here the graph between return loss and frequency?
Yes, sir.
S21, the S11, sorry, S11 and F.
Yes, sir. This is the S11 and this is VSWR graph, sir.
Okay, and why we are taking this notch? What is the reason behind this notch? If we are not taking this notch, why you are taking this type of structure actually, this shape?
This type of structure gives us the exact UWB antenna requirements, sir. So we have considered these as the final one, and the notch. So while having the communication between the transmitter and the receiver, there is a impedance mismatch occurs due to some of the frequencies. So we want to eliminate that frequencies which bring disturbances in the communication. So we put the slot which eliminates the notch with some frequencies are eliminated over that range, so that the disturbances does not occur in the communication.
Okay, thank you. The one question is also there. How can we calculate the mathematically the dimension of these antennas? What is the formula for calculating the dimensions? Like this semicircle dimension or length and width, or what should be the how can we calculate the exact dimensions? This is
Like
my question.
the dimensions of the antenna are given randomly based on the graphs we get in the software, sir.
Is there any formula?
Like for calculating theoretically, there are no formulas for that, sir.
Okay,
We have
but
to
for
assign it randomly and go with different designs.
okay, but for rectangular there is a formula, na, for rectangular patch antenna.
Yes, sir.
Okay, thank you. Any other question? Okay, thank you very much.
Okay, thank you, Miss Jangam Sravandi. Thank you very much for the presentation.
Yes, sir. Thank you, sir.
We shall now move on to the next presenter, paper ID number 149, entitled The Passive Power Limit Estimation for Battery Management Systems and Switch Resistor Equilibrium of Lithium-Ion Batteries, by Indu Priya, Dr. K. Sundararaju, and Maheswari A.
Sir, good afternoon, sir.
Good afternoon.
Am I audible, sir?
Yes, yes, ma'am, you are.
Okay, sir. Sir, is it visible, sir?
Yes. But the screen is very. Please enlarge the screen. It is not full screen.
Okay, sir.
Slide. So the lower button, lower side, left.
Beside the minus sign. The icon beside the minus sign.
Beside the minus sign. Yeah.
Beside the minus. No, the icon beside the minus sign.
The icon is there, na? This is yes. Click this.
So good afternoon, Anandal Yadav here. Myself, Indu Priya. I am a full-time research scholar. My research is fully based on the passive and active power limit estimation for battery management system and switched resistor equilibrium of lithium-ion batteries. Here is a content I have taken through my research is the abstract problem and solution statement, charging characteristic, cell balancing methods, balancing method using resistor, charge power limit, SOC discharge curve, positive and negative electrode for separator, balancing resistor and balancing power, simulation of solid surface concentration at positive and negative electrode, and then the distribution of individual SOC values of a battery pack before to the balancing process, and then I can go into a conclusion of my research. The abstract of this research is fully based on a passive balancing approach for battery packs is electric vehicle. It uses a switched resistor passive balancing to achieve cell equilibrium within a battery management system. This method uses the resistor to equalize voltage at battery cell terminals, eliminating surplus voltage passive balancing in cost effective but has limited energy efficiency due to thermal losses. It is suitable for low power devices and portable applications like electric vehicle, and then can access power constraints during charging and discharging phases using the bisection methods. Nominous features which are used in a battery such as overvoltage, undervoltage, overcharging, discharging.
May I disturb you? Your actually slide is not moving. Your slide is not moving. Go to the first page. Your slide is not moving. Your slide is not moving.
Okay, sir. Can I check it, sir?
Yeah. Please click on first and go to the full screen. That button has, you have not clicked that button. The on the that rightmost corner. Please click that button. Left rightmost lower corner beside minus sign. Beside minus sign there is a
Yes, sir.
yeah this one. Please click.
Yes, sir. So now it is moving, sir.
No. Now
No.
it's not visible. Not visible. Even not visible.
Sir, 1 second, sir.
Please share your screen. Okay, visible.
Okay, sir. So now it is moving, sir.
Yeah, moving.
Okay, sir. So it is fully visible, sir.
Yeah, visible.
Okay, sir. Okay, numerous features such as a battery or the over voltage, under voltage, overcharge and discharge, and then cell voltage balance. Now, my research is fully based on the cell voltage imbalance of lithium-ion batteries. Various cells voltage in the battery can reduces the voltage imbalances. Difference between the voltage is the each battery packs or as much as possible. We can reduces the difference between the cell to cell voltages are defined as the voltage imbalance. If the voltages between the each cells can be varies as much as possible means the voltage difference between the two cells may be as possible, so that in my research I can reduce the difference between the voltages between the two cells. For that, I have taken the problem and solution statement. The problem statement was the cell balancing cause overcharging of some cells and can create potentially safety hazards. Only one way flow of energy from higher to lower. It can complex control algorithm and expansive production cost as need as power electronics interface. For this problem, I have given the solution statement, which means the recovery energy is dissipated into the energy dissipative resistive current shuts the dissipated equalization schemes or best suited for low power applications or low energy charge or discharge rates. It will tend to minimize the loss of energy. Therefore, in order to minimize loss energy and optimize the cell performance, no dissipation equilibrium techniques active balancing scheme needs to be used. The charging characteristic, there are four types of charging characteristic which is used in a circuit, or the undercharging, overcharging, under discharging and over discharging. Under discharging, we can say it as a one or more cells in the battery string receive charges below their minimum capacity was known as a undercharging. For that minimum capacity, we can replace it to one maximum capacity means it can say it as a under overcharging. And under discharging means one or more cells within the battery peak reaches their lower threshold, which means undercharging. Under discharging, then over discharging means deplicated beyond its specified lower threshold level, which means under discharging. These are the four level of charging, four charging levels in a battery. Here is a cell balancing method. The cell balancing method was basically divided into two types, or the passive cell balancing and then active cell balancing. The passive cell balancing was again divided into two types: fixed shunt resistor, switched shunt resistor. Fixed shunt resistor, active cell balancing. First we can see what is meant by active cell balancing and passive cell balancing. The active cell balancing means transferring energy from higher SOC cells to a lower SOC cells, which means an active cell balancing. And move on into the passive cell balancing. The passive cell balancing means equalizes the SOC of a cell by dissipating the energy from higher to lower. This is a main difference between active cell balancing and then passive cell balancing. The passive cell balancing was again divided into two types, which means a fixed shunt resistor and switched shunt resistor. The fixed shunt resistor means we have used as a resistor in a connected in a series or a series manner by using the cells. By using the cells, the resistance are connected in series manner. In the switched shunt resistors means there must be a controller circuit to control the entire process of the cell dissipation. For that, they are using a switched shunt resistor. And again, we can go into an active cell balancing. Means there are two types of active cell balancing: charge shuttling and then energy converters. Charge shuttling was divided into one multiple switched capacitor or a one switched capacitor. Then energy converter was divided into one switched transformer or a shared transformer. Here I have created a Simulink model for the cell balancing circuit using resistor. You can see here there is a battery. Across the battery I have gone through the resistor, and here it consists of an switch. Here it consists of switches. By using these resistors and switches, we can make the cells balanced in a particular manner. Without using the switches, we can make the cell balance in a random manner. So that I have used these switches for making that battery into one balanced manner when the voltage are dissipated from one cells into one another cells. Here you can see the voltages are dissipated. The SOC are to be calculated with the same amount of ranges. If the voltages of the each and individual battery may differ, means it can spoil the health of the battery, and also it can reduces the lifespan of the battery. Here is the control algorithm I have created by using the MATLAB Simulink to control these type of simulation circuit. This is the SOC and current which I have measured using these type of experiment and these type of simulations. The SOC of the cells are balanced due to the different voltage ranges, while even discharge of the cell, which consists of a higher dissipation of the energy, which means the voltage in the some battery of 80% and the corresponding battery which consists of a 50%. By even charging of cells, the 80% should be reduced into 150%, and by dissipating energy of 30% or the major loss of the circuit by compensating these major low passive cell balancing or should be used when the single cell consists of a low voltages, another battery cell which is also divided into one low voltages. This is the charging power limit which I have taken through the MATLAB Simulink. The tool I have used to simulate this type of circuit by using the MATLAB Simulink model. The x-axis which denoted by the time, and then y-axis which is denoted by the SOC. The goal which was to see how quickly the pack might get out of balance after using the discharged and recharged several times. Here the batteries were mismeasured to see how the SOC changes between 20 to 90% when there will be a discharging, and when there will be a charging. It was created for 5 battery packs chosen at random, each of which had 100 cells and had been charged and discharged 20 times. The values of the available voltage at the battery cell terminals is balanced, which is using an resistor in the electrical circuit. Here you can see the discharging curve of SOC for each and individual cells. For cell number 1, the SOC range which discharges in the below or through the 50%, and then cells 2, the SOC range was comes under the 50, and then 60, and then 50. You can see the difference between the 4 types of cells. The SOC ranges can be decreasing from the 80, 70, 60, 50. At last, it can give the moderate even amount of voltages which has been dissipated for each and individual cells. The relative frequency of end of charge SOC have after 20 rounds of charging and discharging, it makes it easier to see how the SOC values are spread out and how they are spread out in general after 20 rounds. The analysis consider the range between the lowest and highest state of charge across all simulator cells over 20 cycles, revealing a margin of 21.59% to 21.73% following 20 cycles. The SOC can spread was determined to be the 0.15%. Here I have given the positive and negative electrode for the separator. The separator, which means prevent the contact between the anode and cathode. At negative electrode, the dynamic graph should be done. For dynamic graph, I have taken the data from drive cycle data and have feed into one MATLAB function. Then by calling that type of program into one Simulink model, I have taken these results. The HPPC power limit was determined by having knowledge of a real state of charge and utilizing sigma point Kalman filtering to predict the SOC. The filtering method, which means a trial and error method, can give the great output by finding the SOC, by estimating the SOC. So that here I have used these Kalman filters in the data set. In the MATLAB function, when I am using the coding for controlling the particular symbolic model, I have used this type of Kalman filtering method to find the SOCs, to estimating the SOCs with accurate manner. In this data set, power versus time profiles were requested from the cell, and the return data were employed by a sigma point Kalman filters to predict the SOC. The testers were calibrated with a true SOC. Initially, the effective resistance were computed, and the hybrid pulse power characteristic method was subsequently, HPPC test was subsequently employed to apply them. Depicts the outcome of these products, initially assuming the cell to be 25 degrees Celsius with a SOC of 50%. The SOC ranged from 10% to 90%. The voltage spanned between 2.8 volt to 4.3, and the current fluctuation between minus 200 amps to 350 amps. Here I have dissipated the voltage from cell to cell variation. From cell 1 variation, there must be a lower voltage dissipated. You can see in the graph 1. And the below graphs are which gives the nominal voltages for each and individual battery packs. The power drops to 0 volt, resulting in no power generation during the charging process. Specific power limits have been estimated for different time intervals. In the first hour, the power limit is said to be 0 and 0.3 kilovolt. From 1 to 5 hours, the power limit increases to 0.3 to 0.4 volt. For the subsequent time interval, of 5 to 7 hours, the power limit further rises to 0.4 to 0.6. Finally, during the last hour of charging, the power limit is considered set of 0.6 kilovolt. Randomly, simulation studies were conducted using the reduced order model to analyze both charging and discharging conditions. Here is I have noted the table when the resistor of battery cells 10 means the power which consists of 1.6. The total power balancing was 322. The time which takes to balance the each and individual cells was 0.2. Likewise, all the different types of resistor balancing cells I have taken, and for that cells I have taken the power and total power balancing cell which is represented by the hours. The simulation of a solid surface concentration at negative and positive electrode. These one also were dynamic profiles. Dynamic profile data I have taken from the NASA PowerPoint, and I have feed into an MATLAB function. Then I have called this function into my model. Then I have taken the negative electrode current collector for a particular time period, and negative current collector for a separator current collector, positive time period positive current collector for a separator, and a current collector which is representative, which is respect to time period. The concentration of a solid surface at the negative electrode or a current collector ranges from 8590 to 8990, while at the negative electrode or a separator it ranges from 8050 to 9150. Similarly, at the positive electrode or a separator, the concentration varies from 9200 to 9980 mole per m. And the positive electrode or current collector ranges from the 9275 to 9425. After conducting an analysis, the electrolyte has been examined. The actual figure displays the ROM value and the results for the electrolyte concentration at the 4 specified locations. The concentration of the electrolyte fluctuation with a range of at different location in the battery. Here, the distribution of the individual SOC values of the battery pack before of the balancing process. As previously mentioned, passive balancing methods were utilized to achieve cell balance. In this study, it is adjust to resistor setting in the switched resistor. To achieve a more optimal balance, one could consider employing a passive balancing technique. When the resistor value is very low, the resistor releases a significant amount of power. The heat generated by the balancers in the battery pack, which means dissipated by the one amount of cells in the battery packs, will require a larger and more expensive thermal control system. For that, we can use these type of balancing circuit to balance the all amount of cells in a proper manner, in an equilibrium manner. However, this process of balancing is completed rapidly. Using larger, more costly resistor and transistor results in a longer balancing time. But it also reduces heat generation. It is crucial to select the appropriate number for the balancing resistance. Here is the passive balancing of cells using switched resistor method. Here is the voltage which is balanced for each and individual cells with respect to time. This undergoes that the lower balancing resistor number leads to a quicker balancing process accompanied by a larger power loss in the form of heat. Conversely, a higher balancing resistor prolongs the battery during balancing during but the author's finding on cell balancing, providing details on the time required to achieve balance and the energy loss of these three cells attested. Furthermore, the condition of the battery pack following the balancing process using 170 resistor in this instant, the power required to balance each was determined to the 0.0992 watts, while the total power needed to balance the battery pack was measured as 9.7032 watts. I have concluded my research work, which means this analysis revealed that the power limit increases after charging and decreases after discharging, with the most significant power during discharge estimated to be 0.9 kilovolt for the first hour. During the 7 to 8 hour of charging, the maximum power was estimated to range between 0.5 kilovolt to 0.7. The application of the 170 balancing resistor successfully balanced an initially uneven pack. Even cells balancing power amounted to 0.09 volts, swimming up to the total pack balancing power of 9.70 volt. Over a duration of 24.81 hours, these approaches contributes to improve battery pack performance, extended lifespans, and ensure safety operation even in challenging conditions. So it can be said that the balancing method is an important way to make sure that the power flow from the energy storage system in electric vehicle is always on and reliable. Cell balancing can also done by using achieve balancing and smart methods. Here I have taken some research for my research, taken some reference for my research. Thank you.
Yes, any question? Any question by any participants? That is a passive power limit estimation for battery management system and register equilibrium of lithium-ion battery. Now, what are the advantages of these lithium-ion batteries as compared to other batteries?
Sir, it will be more reliable compared to the other batteries, sir. If the heat is dissipated, which compares to the lithium nickel battery, lithium ion batteries have a lower heat dissipation, and the voltage which was passes into one cell to cell, it gives a very minimum amount of time, and it has a higher lifespan compared with other batteries, sir. So that we have chooses the lithium ion batteries for this research, and for the research which is based on the SOC estimation or the parameter identification, also the most preferable battery was a lithium ion battery, sir, compared to other batteries.
Okay, thank you. Sir, would you like to ask any questions, sir?
Yes, Madam Indu, I've got one question. If you look at your second last slide, right, the slide before the references, you have said that in the first few hours is 0.9 kilowatts and all that. And then you have said that the conclusion is that this battery performance has improved, right?
Yes,
When you say it has improved, can you provide a benchmark as to how it has improved? Like, based on what has it improved? Based on what standard?
Yeah, how it is improved? Yeah, how it is improved? This is the question. Very important question.
Sir, for balancing a cells, sir, we have used a resistor which is connected with series in the battery cells. For using a switched resistor, we can balance the cells in a particular range of time. For example, if the second cells has been a more voltage dissipation, means we can use the switched resistor to resist the type of battery type of cell, sir. This is the most important thing which I have used in this result.
But how did you know it has improved? What you're telling me is why it should improve. How did you know it has improved? What measurement?
Sir, for existing method, I have used the capacitor instead of resistor. By using that capacitor method, the capacitor can store the power, and later it will delivers the voltage or a current to the battery cells. Instead of using the capacitor, by using resistor, I can see the dissipated voltage, which will be more relevant, it will be more complete. It will be more easy and it will be more standard, which compared to the capacitor, which is compared to the capacitor which is used in a circuit, sir.
Okay. Thank you, Marvindo. Thank
Thank
you
you,
very
sir.
Thank you.
much.
Thank you.
Thank you, Andu.
Thank
Very
you,
nice
sir.
presentation.
Thank you, sir.
Okay, we have now come to the last paper, paper ID number 115, entitled Multi-band Rectangular Two-Element and Slotted Antennas for MIMO, presented by Manisha Kulbe, Priyanhu Bhargava, or Ajay Mehra.
Hello, sir. Sambhav here. Actually, the authors of this paper are not available to present the paper, and also then Manisha Gulbe, which is the guide of our paper, is also busy in election duties. So we are presenting on the behalf of authors. Okay. So
Sure,
me
carry on.
and Akriti Raya is the presenter here.
Yes. Me.
Okay. So, sir, so our project title is multi-band rectangular two-element and slotted antennas for MIMO. Okay. So and hello, am I audible?
So you're audible.
Yes, you're audible. I think, Miss Indu, you need to mute your mic, I think.
Okay. Okay.
Okay, thank you. Okay, carry on. Who is presenting, Akriti or Sambhav?
Sir, Akriti is presenting and Sambhav is starting with the slides and I'll take over later.
Okay, thank you. Carry on.
Yeah. Akriti, can you please present the first slide?
Hmm.
Yeah. So basically, our paper title is multi-band rectangular two-element and slotted antennas for MIMO, and our index is like firstly we can tell you about the abstract and introduction, objective, and the prerequisite, and then Akriti will take over about the methodologies and results and simulations, limitation and conclusions, and other things also. And after that, our abstract is basically in this project a single feed rectangular two element microstrip antenna array is presented. Several slots of are being created in the patches and some at the edges along the y-axis, and two slots are introduced in the middle along the x-axis with respect to the reference coordinate system, so that the various parameters such as working frequencies, S parameter, VSWR, gain, radiation, and efficiency and total efficiency can be improved. This model is designed to operate at multiple frequencies in sub 6 gigahertz of range. We are using the 6 gigahertz of range because the software which we are using, NSYS, we are having that student software version, and the limitation of that software is only up to 10 gigahertz. And techniques such as inset feeding and quarter wavelength transformer are used for improving impedance matching in order to reduce reflections and hence improving various antenna parameters. And the detailed analysis of simulation of the antenna are characterized and various parameters are performing using NSYS HFSS, including an NSYS electronic desktop suite. And after that, in introduction, I will say that as we know that due to the increasing demand of mankind, it is required to develop and improve the previously designed technologies. The same applies for wireless technologies as well. If we talk about the internet, we all want fast, reliable, and flexible network in order to fulfill our daily needs. If we talk about the 5G, two frequency specifications that are allocated for it to use a subband like 6 gigahertz, but in order to improve the bandwidth, data latency algorithms for improving network and data security, we are improving beamforming with the user devices, etc. Development in 5G technologies and devices have to be done so that new revolution can take place in the field of IoT devices, which is Internet of Things. And our main objective and prerequisite are to design and simulate and a 5G band, which is based triple band antenna design using NSYS software. And we also wanted to design and analyze multi-band rectangular two-element and slotted microstrip antenna for MIMO, which is multi-input and multi-output application, with a focus on improving performance parameters like gain, directivity, and radiation for 4G and 5G and future wireless communication systems also. And if you are talking about like a 4G switch between 4G to 5G, there we need a huge infrastructure for the switching. But in other technologies, like if we talk about the 6G and the 7G, so for switching from 5G, we do not need a much higher infrastructure. So, yeah, so Akriti will take over from this.
Yes, sir. So now we are moving towards the methodology, and here in this slide, which is the single element microstrip patch antenna, this shows the front view and the back view, which illustrates using the Rogers duroid. And why we use this substrate? Because this is a material for which our microstrip design could operate in the 6 gigahertz range, which have a relative permittivity of 2.33 and a thickness of 0.78 mm. In this slide, figure 3 and figure 4 shows the front and back view respectively of the two-element microstrip antenna array, such that it uses two methods, inset feeding as well as the quarter wavelength transformer methods. Now, why we use these techniques? Inset feeding is a popular technique which I read through past papers in microstrip antenna, which is used to attain better impedance matching. So in this method, the feed line is not connected to the edge of the patch, but instead it is inserted into the patch at a specific distance. Now this distance is known as inset feed point. Quarter wavelength transformation is used with inset feeding. It is used to match the impedance of the feed line to the input impedance of the antenna, which can be different from 50 ohms. So the length of QWT, which is quarter wavelength transformer, is chosen to be approximately quarter of the wavelength at the operating frequency, as its characteristic impedance is calculated based on the impedances. Figure 5 illustrates the E-slotted antennas at double sides of two elements and at a center slot in both the elements. Now, why we use the slotted antennas? So, by introducing the slots in the two-element array, we achieve the better impedance matching, reduced reflections, and enhanced our basic key parameters like gain, directivity, radiation efficiency, and could effectively modify the resonant behavior of the two-element array. In this slide, this shows the S parameter, which illustrates a deep dip, indicating the dip in this graph indicates a good match between the feed line and the antenna impedance. This S parameter is for the two-element microstrip patch antenna, which displays multiple resonant dips or valleys, each representing a frequency at which the antenna is resonating and efficiently radiating or transmitting the power. The lower we understood that the lower the value of the S parameter at these resonant frequencies, the better will be the frequency matching and more will be the antenna more efficient in working. In this, the x-axis represents the frequency and the y-axis represents the magnitude of the S parameter, which is in decibels. This slide illustrates the plot for two-element microstrip patch antenna with slots. These represents the multiple resonant dips or valleys. This is the VSWR plot for single patch element microstrip patch antenna. Here we got a sharp and a narrow dip in the VSWR curve, reaching a minimum value close to 1. This narrow dip indicates us a better impedance match and efficient radiation at a specific resonance. This is the VSWR plot for the two-element microstrip array with responses with multiple dips, peaks indicating multiple resonant frequencies, which gives a broader bandwidth. This shows the graph with slots antenna, which is shown with the multiple frequency dips and peaks indicating a broader bandwidth. This gain plot for single element microstrip patch antenna indicates that this antenna design has a maximum gain of around 6 decibels. The gain of the antenna is basically a measure of how much it is concentrated and directs its energy in the direction. This is the simulation output of a single antenna, which is shown in the table in terms of peak various parameters like peak gain, power input, power radiation efficiency, total efficiency. This is the gain plot for two-element microstrip antenna without the slots. Typically show the radiation pattern in multiple directions to depict the antenna array focusing on radio waves. And this table similarly simulates the antenna parameter outputs for different frequencies. This table for which has parameters like peak directivity, peak gain, accepted power, system power, radiation efficiency, system efficiency. This depicts the gain plot for the two this depicts the current density, which is in in the single plot, and this is shown in arrows. This is shown in the decibels. The arrows here represents the energy bifurcation here. This is for two-element microstrip antenna array. Here, this shows the concentration of current density over the substrate, and we can see that the current density is closer to the patches, to the inset feed line. Here it is the two element for antenna array with slots. This is the hybrated version, and this is the current density and this is the electric field points. Now let's come to its limitations. We have mutual coupling. Close proximity of antenna elements can lead to distortion as well. Bandwidth constraints, polarization diversity, pattern distortion, radiation patterns, size and integration. Since ANSYS HFS's student work version, as Sambhav told you, we can only utilize it up to 10 gigahertz only. Now, the conclusion of the paper was this paper presents a single fed rectangular two-element microstrip antenna array using Rogers 5870 substrate, I told you, which has a relative permittivity of 2.33 and a thickness as well of 0.78 mm. Inset feeding and quarter wave transformer techniques are employed to improve impedance matching and reduce reflections. The simulated antenna exhibits multi-band behavior, achieving peak gains of 7.66 decibels at 6.26 gigahertz, 7.73 decibel at 7.7 gigahertz, and so on. The radiation efficiencies at these frequencies are 77.5%. 88.89 and 84.53% respectively, with the total efficiencies of 68.54, 88.64 and 77.91. We have a few advantages as well. Since it has a compact size, these antennas are relatively compact, making them suitable for integration into smaller devices. Multi-band operation, it can be designed to operate in multiple frequency bands, allowing for compatibility. Polarization diversity, ease of fabrication. The antennas can be relatively simple to fabricate, especially when using printed circuit boards. And tunability. We have further scopes as well. Improved bandwidth and efficiency. We can focus on designing antennas with wider operational bandwidths, mutual coupling, beam forming and pattern reconfigurability, integration with meta materials and meta services, compact and conformal designs, and the last was not the least, it is hybrid antenna structures. Exploring hybrid antenna structures can combine different antennas, for example rectangular, slotted, to leverage the advantages of each design and improve overall MIMO performance. Here are the references we used. And thank you so much. I'm all ears to hear your suggestions.
Yeah, any queries by any participant regarding this very important topic? Firstly, thank you to Akriti and Sambhav for
Thank
Yeah,
giving
you.
thank you, sir.
very beautiful presentation, very
Thank
innovative.
you so much, sir.
I would
Thank
like
you.
to ask a question. Have you fabricated and